Now we are coming to the casting design consideration. What are the consideration for getting the best casting product? So first one, volume by air ratio. First, volume by air ratio means ratio stands means volume to the surface area. Mathematically we have written volume by surface area. Volume of ratio is the critical to avoiding the premature of the solidification of that particular metal casting, okay, and the formation of the vacancies. Means for that is the low volume air ratio, that is the higher volume air ratio. Means sometimes why we are taking that things. Now sometimes when we pouring the molten metal to the particular getting system, then it will come to the particular mold cavity. So in case of low volume air ratio, here it will take the particular positions easily. In case of higher volume air ratio, so it will take the positions easily, and sometimes we are taken care about the higher volume air ratio, maybe it will create some vacancies. So means some portion may be infilled. So every casting process, so you taken care about that things. Means molten metal must be passes throughout the particular volume of that particular cavity. Otherwise, some parts will not fill up. So that will create some defect. Okay. So volume and air ratio, that is one of the important design consideration in case of casting. Second one, heat mass. Means what happens? Now avoid large heat masses in the location of distance to risers. Means what happens? Now position of the heat mass means here that is the riser and here is heat mass. Means you consider that is the cavity. So and through the riser, the metal, molting metal comes to that particular heat mass or to the cavity. Okay, the distance is more. Sometimes what happens, maybe in the riser some part of the molten metal may be start the freezing. After that easily the molten metal does not come to that particular mold cavity. Okay, so the produced product will be defective. So always you taken care about that things, means that is the bad positions, means that is the better positions, means the position of the riser and heat mass means mold cavity, the positions of that two things will be nearby. So easily the molten metal comes through that particular mold cavity easily. Okay, means it does not take freezing or it will come to that particular positions easily, means that is the better things. Third one, do not feed a heavy section through a lighter one. Means we have seen that is the heavy positions of the mold cavity, means bigger position, and that is the lighter positions. Okay, that is the riser. Okay, but heavy positions in taking some distance, but light positions the nearby positions. So we do not follow that things. Always we kept the heavy positions nearby the riser. Always we kept the heavy positions nearby the riser, and we kept the light positions at the distance from the riser. Okay, that is the better things and that is the bad things. Okay, that things also we are taken our casting design considerations. Another, junctions. That is the particular right angle position is there. Okay, and in that cases we are taken also some right positions. Means when passes through the molten metal through that particular right positions, so molten metal does not flow properly. It will, when it will come to that particular corner position, directly we attach to that particular corner position. That corner positions may be eroded. Corner positions may be eroded when during flow of the molten metal. So always we avoid the corner positions. Always we avoid that particular corner positions in every section. Always we avoid the corner position. When we flow the molten metal erode that part. Okay, easily erode that part. So always we avoid the corner positions in the particular getting systems or particular mold cavity. Always we are taken some particular curve shape. Always we are taken some particular curve shape. When we using that particular curve type shape, generally does not erode the corner positions easily. Does not erode the corner positions easily. Okay. Always we are taken some particular curve position to that particular getting system of that during casting times. So the does not easily erode it. Another prevent plants from weakness, that is the corner positions, and when we are seeing that is the columnar grain structure, that is the columnar grain structure. When that type of columnar grain structure has been formed, so we have seen that the corner position is very weak. That corner position is very weak, means maybe easily it will broken during handling time of that particular product. So when we are taken that type of curve positions, the columnar grains also formed. So using that type of curve positions does not broken easily. Okay, but that corner positions are very weak portion. Reduce turbulence. So when we sending the molten metal due to position of that corners, sometimes turbulence has been taken to that particular metal. Sometimes turbulence has been taken to that particular metal. Okay, but using that type of curve positions does not taken any turbulence to that particular getting systems. Okay, so always we using some curve position, we avoid the turbulence. The position of the riser and castings. So always we maintain the calculate the distance from riser to casting. Means large distance is not better. Always we maintain the short distance between riser to castings. So in that way we easily send the molten metal to that casting process, and easily it will take the all spaces of that particular mold cavity and also produce the good product. Okay, always we avoid the higher distance between riser and castings. Always we avoid the more distance from the riser to castings. And some use of chills, the position of the chills, we use the particular chills to the particular position, because using the chills the directional solidification it has been taken to that particular product. Means using the chill in that from that particular positions, the heat will be easily goes out to the surroundings, and means in that position the solidification has been started to that particular positions. Means easily in that particular position first heat will be removed easily from that particular positions, and here the first solidification takes place to that casting product. That are the different casting design considerations, and that will be we have followed during casting times. Means that is the very important point in case of design of castings. And end of this lecture, the student has learned about the crucible furnace construction, use, working principle, some advantages, disadvantages of crucible furnace, means cupola, induction furnace, reverberatory furnace, open hearth furnace and arc furnace, and also they have got some idea about the casting design consideration. And thanks to all.